All right, it seems to have leveled off a little bit, so why don't we get started? Welcome everyone to our second dive into AI workshop. It's part of the Building Bridges project. My name is Alex. I am the AI training lead with Building Bridges, and we're very excited for today. We're glad you could join us. We have a fantastic group of people joining us to discuss AI ethics and share their experiences with ethics and AI. Lots of exciting stuff going on in this space. Lots to wrap your head around. It's not easy all the time. So we're glad you could joining us for what's sure to be a very interesting discussion. Let's go to the next slide, please, Sheila. I'd like to begin first by acknowledging and respecting the First Nations, Métis, and Inuit peoples on whose traditional territories CU's work is conducted across Canada. We strive for respectful relationships with all Indigenous peoples as we search for collective healing, true reconciliation, and honoring these beautiful lands and seas together. I am coming to you today from Kjipuktuk, otherwise known as Halifax, the traditional and unceded territory of the Mi'kmaq. We are all treaty people. We have the next slide, please. Before we get started, I have a few housekeeping items to highlight. We'll be monitoring both the Q&A and the chat box today. You can find the chat box on the right side of your screen, and the Q&A is an option at the bottom. You're welcome to use the Q&A to ask questions to the panelists and the chat to connect with the other attendees. This workshop will be presented in English. Zoom does offer live captions and automatic translation features. You have the option of turning them on or off in your control panel. You can set the caption and the translation language to that of your choosing. Please note that this session is being recorded and will be shared through our social media channels and website to be used as a public resource. If you have any questions about the session or are experiencing some technical challenges, please connect with us over chat or send a quick email to info@ceusatlantic.ca. For today, the run of the schedule for the next couple of hours. Can you go back to the last slide, please? So we'll start with just a quick introduction of building bridges in CUs and some get to know you questions for you in attendance. We'll get into the meat of the workshop with our panelist talks. We'll be starting off with Anne Yen. Second, we will have Jim Pro. And finally, Frank Rudzix will be our third speaker. We'll take a quick 5-minute break at around the top of the hour. And then we will come back for our discussion and Q&A session for about 40 minutes, which I'm really excited for. After the session today, our partner organization, ONC, is also offering another workshop session detailing and demoing their hydrophone anomaly model. Very exciting. Hope you can attend that as well. We'll be including some links to that for you in case you have not registered already. We got a lot to get through today, so why don't we get started with some Mentimeter questions. If you haven't used Mentimeter, it's just a tool for live polling, and it's a bit of a good way to get to know each other and learn a little bit about the group that is here together today. So we'll start off. In order to access Mentimeter, you can just go to menti.com on your phone or on your computer browser. And there is up top, you can see number code, just enter that, and that will take you right into the poll where you can answer, and your answers will show up live on the screen here. So we'll start off, very easy one, not very skill testing. Where are you right now? Where are you joining us from? For us, most of us are based in Halifax, but we know we have a couple of people joining us from across the country, which we are always excited to see. a good concentration in Victoria. Lots of us from Halifax. We have a couple in Quebec and Ontario as well. And I believe Alberta. Ah, Newfoundland showed up. Hello, Newfoundland. All right, we've got a decent spread. Glad you could all make it. Don't worry if you haven't submitted, but we can move on to the next one. Hopefully everything is working all right for you. What sector are you working in? So oceans obviously spans a lot of different contexts of work. And we're hoping to be able to reach people working in all kinds of different contexts, because AI is not necessarily limited to just one area. Neither are the oceans. Hey, a lot from not-for-profit. There's some from government and academia as well. A couple of NGOs, Indigenous organization, great. And one student. We're kind of all students here. All right, thank you for your responses. Good to see a good spread of show from all across different areas. Why don't we move on to the next question? What stage are you at in your career? We have some people who might be still in school, they might be kind of early on in their career, might be a little bit further on. AI is going to be kind of new to most people, no matter what part of your career you're in. And also, we've split the answers into ocean or not in oceans. It's all right if you're not in oceans. We're still happy you're here. And a lot of what we're talking about is going to be relevant to AI, no matter what sector you're in. Right, a lot of early career, a couple of people from not in oceans, and a couple a little bit further on, and some more students. Great. All right, thanks everyone. Let's go to the next question. All right, so we'll get a bit more conceptual with this one. Where are you at in your AI learning journey? We're framing this as being kind of on the beach. So you can place kind of like you did on the map before, kind of where you feel you're at in your AI learning journey. So kind of up on the sand, still kind of not super involved with it, not showing up a lot, or maybe you're, pardon me, maybe you're at the other end in the water and you are knee deep, or maybe even just you can't feel the bottom anymore, or maybe you're like me, kind of somewhere in the middle. You got your feet wet, you got some waves lapping up on your feet. It's always interesting to see how this ends up getting populated. Oh, great, it looks like we've got a good spread. So a few people kind of still not sure, some people who have some awareness, some who have a little more knowledge about what's going on, might be even working with it every day. Oh, that's great. I'm glad we could get such a good spread. All right, we've got to slow down in, oh, no, a couple more responses showing up. I think that's most people by now. We got about 50 joining us today, so that's majority of people responding. I think we can move on to the next question. All right, this one's a bit more open-ended. You should be able to submit a couple of different answers just that you type rather than pick. When you think about AI ethics, what are the first three things that come to mind? And in the middle, we're going to have a word cloud that pops up out of everyone's responses. Kind of get to map a little bit the headspace of what this is all looking like in all of your heads. Piracy, accuracy, responsibility, explainability, integrity, yeah. Some transparency, misunderstanding, yeah. AI ethics is pretty far reaching. There's a lot of different pieces of AI and where we interact with it that it touches upon and that are really relevant to how we go forward with this. Bias is a common one that's showing up in privacy, security. How do we deal with AI safely? How do we use it responsibly? Awesome. All right, so we still have a couple of answers coming in, but to get this show on the road, we can probably close the Mentimeter for now and go back to the slideshow. Thank you, everyone. Appreciate that. So now that we've learned a bit about you, I'll share a little bit about us, what we do here at CU's with building bridges as well. So CU's is Canada's integrated ocean observing system. Ocean observing systems around the world are bringing to light the sea of data that was previously obscured from those not directly involved in the research. By centralizing those repositories into the OOS framework, possibilities for utilizing these assets are growing. Next slide, please. CU's joins this international framework to contribute its data to the international effort, continues to gain speed. Canada's ocean of data fills vital gaps in global observations through our work at higher latitudes and our enduring time series. Our contributions are important to an OOS future where fair data are widely available and well utilized for sustainable ocean health and economic growth. Next slide, please. Through CUS, we hope to improve access and visibility to high-quality observational and model ocean data and information, increase collaboration and coordination in the ocean observing community, increasing national coordination while remaining regionally focused, and contributing to evidence-based decision-making in the ocean domain. And this is part of where building bridges fits in. We have the next slide, please. Building Bridges is a project undertaken by CUS and our partner organizations, leveraging our collective capabilities, expertise, and infrastructure to promote wider adoption of and familiarity with AI in the ocean sector. It aims to increase the adoption of AI in the ocean sector by addressing barriers along the AI pipeline. This includes developing new AI tools, enhancing expertise through training materials, and engaging with the ocean community to identify AI opportunities and facilitate access to AI-ready open data. Next slide, please. Through a collaboration of 4 national academic and not-for-profit partners across Canada, Building Bridges will address multiple components of the high-level artificial intelligence pipeline, which begins with having the knowledge and skills to identify and develop solutions for scientific questions or problems which may be solved with AI. Next slide, please. To accomplish this, we'll first engage, talk to people, talk to organizations, see what works, see what doesn't, what are the gaps, the needs, the opportunities, the challenges, find out what makes it easier for you to work with AI or what's made it harder, what barriers you're facing. And based on that, figure out our approach to how we can help address that. We have several activities planned, workshops like this one, to bring the ocean community together and really talk about what the opportunities are with AI, to help connect people, provide a forum so that people can share best practices and knowledge and further advance AI in the ocean sector. And further learning our opportunities, like we mentioned, in the form of online courses, the first of which will be online soon, as well as proof of concept models to demonstrate potential applications of AI in the oceans. And we will achieve this by leveraging the connections and expertise of SUSE and our partners. You have the next slide, please. All right, so here is why you are all actually here. For our first presentation, I would like to introduce Anne Nguyen. Anne is the Chief AI Officer at the Quebec Council for Innovation, driving the adoption of AI across the province. She's cultivated a data-centric culture, fueled innovation by expanding opportunities through analytics-driven products, led digital transformation efforts, and managed large-scale projects. A Harvard Business School graduate and certified in product management and Lean Six Sigma, Anne is a passionate advocate for women in science. Anne, it is all yours.
Thank you so much for having me. And as you may see, I might be a really boring person. When you do that much curriculum, that's what happens. And I'm also a mom of two, so that's why it's so important for me to be here today, because I think we have a big role in giving our future generation all the principle on using AI in an ethical way. So thank you again for having me. Quick introduction about the Conseil de l'innovation du Québec. Le Conseil de l'innovation du Québec plays an important role in helping innovation grow in Quebec within 4 pillars. So we are here to understand, we focus on understanding the role of innovation and all the stories behind innovation. So how it happens, how much was invested, and when businesses and organizations choose to innovate, and usually is to survive. Once we understand, we better play our main role, which is advising the government on program and public policy. And we are also there to accelerate innovation, because in Quebec, there are 693 organizations that helps innovation. So we kind of guiding people around the right resource. And finally, we're there to promote, which is a really nice way to say that we don't have money, but we are a really enthusiastic person. So why am I here to talk about AI? Is because a year and a half ago, the government said, AI is such a powerful tool that we must leverage for economic growth, but we needed to do it wisely and responsibly. Quebec has such a strong AI ecosystem with a full value chain, from fundamental research to applied research to commercialization to real-world adoption. So my main role and my team's role is to be there and bridge the gap between each of the key stages. And I also teach at Université de Montréal. My topic, you'll see again that I'm a really boring person. My passion is supply chain and AI. So that's what I'm teaching also at Université de Montréal. Just to take a few steps back on time, a year and a half ago, I don't know if you remember, there was a shock. Elon Musk, Yoshua Bengio all signed a pledge to say, you know what, world, we need to stop developing AI. And as you know, nothing stopped at that moment, and nothing will stop now. But the Quebec government gave us the task of leading a collective discussion on the development of responsible AI. This work resulted in a publication, Prêt pour l'IA, which include a 12 main recommendation and 25 additional recommendation, total of 167 page in French, but thank God there's a AI now. So you can use Notebook LM if you're familiar with Notebook LM. It's an application from Google Lab. It creates for you a really interesting, you can podcast around subject that you may input in. For example, if you put our report Prêt pour l'IA in Notebook LM, in 30 seconds, it will create to you a really nice podcast on how we organize those 37 recommendations. First, on regulating AI, how can we prepare the future challenges, because AI has an impact on workforce, democracy, environment, as well as art and culture, especially if we come to to talk about copyrights. We also give recommendation on how educating all citizens from kindergarten to the workers and reskilling. We also give recommendation to promote research and development, not only in technology, but also the human and social dimension, as we're talking today about ethic also. And we want to make sure that Canada stays on the top leaders, and people can be really cynical and say, we are such a nice country, but are we powerful? Yes, we are, because we're ranked seventh for Quebec, but fifth for Canada in the AI index, which means that do we have the infrastructure to develop and use AI? Yes. So all the question about do we have the mindset of research and development? The answer is also yes. And finally, do we have the right skills and foundation to create our own application of AI and commercialize them? Also, yes. So we are fifth in the world. So I think we should be really happy about it. A short history about AI, because I think it's important to remind people that AI didn't start with Gen AI. Yes, Gen AI really helped democratization of AI, but it all started in the 50s. And here you see snow. It's not because I'm really nostalgic of 2 weeks ago in Quebec, but it's because it's all started a long time ago. Just imagine yourself in the basement of Dartmouth College in the summer of in the 50s. So a small group of scientists were meeting, and they're really excited, and they have one big question. And the question was, can machines think? And it was the beginning of the greatest question in technology, because everything and every effort was made towards that direction. So can machine things? And the answer was the beginning of what we know AI as today. But suddenly, during 20 years, people that were really excited about AI started to be, are we sure that it is the right direction to go? And AI winter was started to be a concept and say, you know what, we're not too sure that AI is the answer to complex question. But suddenly, in the 2000, people starting to realize that like fish swims in water, human swims in data. With the rise of big data and the powerful computers, we are here today with AI Renaissance. So Yann LeCun, Yoshua Benjo changed AI with deep learning. So their model learns from big data and get better over time. So this work that started in the years 2000 made today what's AI possible. So yes, AI mimic the human brain, because like brain, it processes and learn from information to make decision. Just like brain uses neuron to send signal to make decision, uh, the AI uses artificial neuron to process data and make prediction. And I want to be really careful, because we're talking about ethics today, that AI doesn't make decision, AI makes prediction. And then you as human will take the decision to apply the prediction or not. And the brain learns from experience, and AI does the same thing with train large amount of data. And the brain is also great at recognizing pattern like faces, sound, music. AI does the same thing by recognizing pattern in data, such as speech, images, even music composition. So we all know a bit more about AI, because words like machine learning, simple machine learning, so spam filters, Netflix recommendation, bank fraud detection. We also hear a lot about deep learning, so facial recognition, machine translation, medical imaging analysis. And we also hear a lot about neural networks, so everything related to Gen AI, self-driving cars, all those concepts are here today. And I have a small Mentimeter. So you have a QR code here, and I want to make a small exercise with you throughout my presentation. So it's called the rose, the seed, and the thorn. So let's start with the rose. So you'll be able to see my first question. So my first question, oops, sorry about that. So my first question is, what is something you find beautiful, inspiring, and useful about AI? So I'll give you a few minutes to answer the question. Were you able to see so the code is on the screen right now. So what is something you find beautiful, inspiring, and useful about AI? Healthcare outcomes. Robots are cool. Yes, they are. Creative, flexible, efficient. The complexity of the problem it can be able to solve. Yes, it is scalable. It is transformative also, efficient. I think we all around the same strength about optimization and also, sorry about that.
Excuse me, Anne, are you able to share the QR code again? We have a couple of attendees that missed it. Or if you
Oh,
have the link that you could share in the chat, maybe?
oh, sorry.
That's okay.
Let me see how to, here. Okay, just give a more couple of minutes, maybe 1, 2. So training, simplification, research, efficiency. Excellent. So I think people are starting to understand a bit better how AI can be a bit stronger or be complementary to human brains. And that's why I think at some place AI can be stronger than humans, but we need to be really pragmatic about it. There are 4 areas where AI can outperform humans. So we have AI can process and analyze a vast amount of data much faster than human. For example, AI can quickly shift through huge data sets for tasks like predictive analysis and real-time monitoring. When I worked in healthcare, I knew something from experience. So I used to work at the OR, and I knew in the spring that I need to have more people working on orthopedics because people will fall on the ground and comes with broken hips. But now with AI, we can use the data from the weather, ground condition, population to predict where we'll need to have more people in orthopedic specialties at the OR. So this is where AI can be a bit stronger than human, and it can work continuously without need of rest. Unlike humans. So this makes ideal for tasks like traffic management, voice assistance, where real-time responsiveness is required. So thanks a lot for participating in the Mentimeter. But yes, AI can be stronger, but AI can be weaker from human. And I think we have qualities that AI won't be able to outperform. So the first one is candidness, doubt, and intention. And I think it's really important that those three competency are not seen like flaws, but seen like really solid competency that will make always us a bit stronger. And the story I always tell when I talk about candidness, doubt, and intention is, when I was young, my parents spent 2 years in a refugee camp, and when they finally arrived in Montreal, my mom opened a small sewing business, but every day she got robbed. One day I came after school and she was wearing a nun's dress, so religious dress, and she said to me, "No one will dare robbing a nun." And you know what? She was really right, because from that moment she stopped being robbed at her shop. But now with AI, if you ask the question about what do I do if I don't want to get robbed in a house, in a chateau, in a swing shop, it will always say the same thing. So we need to inject our imagination into AI if we want to continue to innovate. And that's really important if we want to still have that human and machine coexistence. And the coexistence between AI and machine needs to be led by the adoption of responsible AI. We have a principle on the responsible AI well-being. So AI should improve lives, autonomy, respect human choice, justice, fight biases, and promote fairness. And as I'm saying all those things, I know that AI today is not where we thought it would be, because sometimes it can increase biases. It's not helping democracy. So the conversation we're having today is so important. And I think for the most important part is to engage people in human agency. In the age of AI, human agency matters more than ever, because it gives you the empowerment and the knowledge to act when you see a result that comes from AI. AI today pushed the boundary really far away, and I'm just going to take more couple of minutes, and I'm going to send the presentation to the organization and give the mic to Jim and Frank after that. But today, AI pushed the boundary very, very far away, because we have robots, we have application that is able to take someone's voice and make a whole podcast. We're able to make archive pictures come alive. We're able to create 45 hours of presentation within few minutes using Gamma. And somehow some people are still really afraid of AI, and that's the conversation we need to also have, because the adoption level of AI in Canada is only 3.7%, and we have a 27% of Canadians that are using AI without knowing, and we want to shift from using AI without knowing to intentional use of AI. And when you know how to use AI and understand all the risk around AI on data privacy, cybersecurity, lack of transparency, copyrights, hallucination, excessive resilience, suddenly you manage to use and choose wisely the AI that you want to have in your daily life. I have another question, and the other question, I have the Mentimeter here, is the thorn. So with the thorn comes the question, and I'm just going to leave the QR code here for a few more seconds. And the thorn is, what challenges or risk related to AI makes you feel uneasy? So from the answer before, you said powerful, efficient, creative, and with the thorn is we going to the opposite way. So what challenge or risk related to AI makes you feel uneasy with AI? I'm gonna put the QR code again. Here you go.
And it looks like we're having some issues getting into that poll question.
Oh, okay.
They
So
may still be stuck on the rose slide.
this one? Oops, sorry.
The QR code does go to the rose slide, I think, but you may be able to just go from that slide and move on to the thorn.
Oh yeah, can you see it now?
Try hitting present at the top, the big blue button.
Is that here?
Yeah.
No, it's not working. So because we are in a small time frame, I'm just going to move on, and maybe we'll shift the conversation within the 40 minutes of Q&A after that. But just quickly, this year we made 200 presentation, and we collected data from almost 27,000 people, and people were really afraid of the impact of AI on democracy, losing our compassion, the impact of AI on environments, losing our critical thinking, and will we be able to create algorithm that will foster more inequality? So I think those answers are quite the same that we will find in the Mentimeter. So after maybe Jim's presentation, I'll be able to maybe collect and present more of your answer. And finally, what I wanted to present to you is people are afraid of losing their jobs because of AI, but in all transformation and technological transformation, there are also new roles that rises, and those new roles are there for you. So within the 5 and 10 next years, we will see more and more new roles coming. At the same time, I lived the transition from internet to without internet and internet, and I saw those new roles came with e-commerce and also webmaster that couldn't exist without the internet. So there are still hope. And also about ethical AI, if you don't know where to start with choosing your AI model, and you want to make sure that you choose wisely, Hugging Face created a community of 2,600,000 developer of AI and user of AI. And every time there's new model, they give a ranking. So the model is good in math, chemistry, talks like a PhD, has an impact on environment. So those metrics will make you decision maker a bit wiser and more respectful of your value. And finally, if you're still discovering a bit about AI, those are three books that will always follow me. So Co-Intelligence by Ethan Malik, and also Harari with the 21 lesson for the 21st century, and also The Big Nine from Amy Webb. So I'll leave the mic now for the other presenter, and sorry for the technical issue.
Thank you so much, Anne. That was far from boring. We have some reading to do. We have a little bit of time for some questions for Anne, if anyone would like to ask now, or you can save it for later. We may also have some time to return to your Mentimeter in the second half if you like.
Yes, perfect. I'll send a link in the conversation.
Excellent. So if you have any questions for Anne right now, you can enter it in the Q&A box, and we will field that to her. You can also ask it in the chat, and maybe she can answer them typing during one of the other presentations, or you can wait and hold on to it until later in the workshop. For now, it doesn't look like we have any immediate questions, so they're holding on to that for later. So thank you very much, Anne. That was a great presentation. Oh, we do have one question. What are the metrics for Canada's rank in the world in AI? Oh,
Canada is 5th in the world. So the study is AI Index. The report is Étude Tortoise. So it's a universal index made, I think, 2 years ago. There's a new ranking right now, and I think Canada just dropped a little bit, not because we're not giving all the effort, it's just because other countries like France were injecting a lot of money into their AI infrastructure. But still, 5th, it's really great.
All right, we have one more from Tim, but for timing, we will probably go to the next question. Tim, if you want to put that question in the Q&A box, we can maybe have Anne answer it during one of the other presentations, or we can come back to it in the second half. For now, thank you again, Anne. We will move on to our second speaker, Jim Provo. Thank you for joining us, Jim. Jim is the Chief AI Officer at Scarlet Nova. He has more than 2 decades of experience in software, automation, and data science. He received his Bachelor of Engineering from McMaster and his Master's from Queen's University. He's a strategic advisor, previous TEDx speaker, father of 2, and wishes that he could still play sports as well as when he was younger. In his own words.
It's not wrong, unfortunately. Hello, everyone. Is my audio on? Just want to make sure you can all hear me.
Yeah, you're all good.
Wonderful. So, bonjour, everyone. Welcome from the beautiful city of Ottawa and a gorgeous 25-degree here. The weather's finally catching up with us. My name is Jim Provo, and I'm honored to be here to speak for the next 16 to 19 minutes about ethics, bias, and discrimination in data. First of all, though, big thanks to Anne out east of me. A wonderful presentation, and thank you so much for sharing your knowledge and your experience. If I summarize all of AI, almost all of AI, down to 6 words, I would say that you can say that artificial intelligence is just having lots of data and a known right answer. Now, within those 6 words is a tremendous amount of implication. If your data that trains the model is biased or lacking groups, you have challenges and problems. Known right answer has lots of density to it. The joke I like to say, the dark joke I like to say is, ask an AI, what's the best way to fix climate change? The answer? Kill all the humans. Oh, well, hold on. No, I didn't mean that. Okay, well, what did you actually mean? Right? So the amount of effort and thought required to make sure that you have historical data that's good and strong and well, and a known right answer that solves what you're actually trying to do is a tremendous amount of the actual work and effort that is required to bring AI to production. What I'm going to talk about today is one facet of that, which is, ethics. Ethics has a lot of implications and work and effort behind it, and we'll get there. But first of all, I want to point out that it is not my place as a citizen to say what is right and what is wrong. I'm not going to come here today and kind of wax poetic about AIs that do good things and bad things. That is up to sovereign states. That is up to us as a collective whole. But there are frameworks and mechanisms upon which we can define and explain ethics. I will pause for a second, though, and I will say that I can't see chat windows or stuff. So Alex and group over at CIUS, please interrupt me if there's a question that I'm not unable to see.
We got you.
Thank you, sir. So if all of AI is lots of data and a known right answer, as Anne rightly pointed out, when we question us about whether or not machines actually think, they don't. We're doing statistics. We're doing statistics at a massive scale, but all we're really doing is making predictions as to the next word or thought or number or fish, whatever the thing you're trying to optimize for. That has tremendous implications as to the type of data you're going to be keeping. The volume of it, how quick it is, the unit of scale. Do you track at a per minute rate? Do you track at a per second rate? How do you store that stuff going forward? Right? The quality of how these things really matter, not only from the quality of good or bad, but also from the philosophical term of its properties and things that are important to you. One example of bias that came out recently, although this is about a year old now, is a machine vision soap dispenser in Southern California. So does this video work? You know what? I haven't actually been able to get the video to work in Google Slides. I apologize for that. But nevertheless, if all of AI is a lot of historical data and a known right answer, then if you want to build a soap dispenser to drop soap in someone's hand, the training data you're using is actually pretty simple, right? Give me 1,000 examples of a hand underneath and say, this is a hand. That's your known right answer. Give me 1,000 examples of pictures of not a hand and say this is not a hand, and then train the model to say figure out the difference between the two. Now, in this case, in this example, the video would show a very light-skinned hand that goes underneath and soap comes through, and then immediately after, a dark-skinned hand that goes underneath and the soap doesn't come through. I would argue and reinforce what Anne had already mentioned, that it's not an AI's fault because it's not thinking. It's just that as we trained the model to identify hands, it was probably giving a lot of examples of light-skinned hands and very few, if any, examples of dark-skinned hands, and it was unable to tell the difference. So there's bias in your training data that can come through. There's bias in terms of representativeness, statistical characteristics, the quality of the information. Your entire architecture of your entire system can have bias in it as well, right? There's all these types of things that come together to understand and explain where bias can come from. And just for time, and I know we're a little bit late, I'm going to skip over some of this stuff, but if people have specific details I want to talk about, more than happy to bring it up afterwards in this chat. But I also want to highlight that a lot of this stuff is not figured out right now, right? There's a lot of details around technology that is still moving in the world. We're seeing a big push towards cloud. I would personally argue that the market incentives are not making us move towards a place that is more ethically sound and unbiased, right? Move fast and break things is fundamentally different from the idea of, wait, are we making sure everyone is diversely stakeholder and represented in our groups? And what do I mean by finding blonde-haired women? Let's talk about a story. So one of my previous jobs at Lixar, a professional services company in Ottawa, hi Bill, hi Emmanuel, everyone else if you're out there, we got this really cool project a couple years ago to work on a karma-connected sports car. It was going to CES over in Vegas, and we were doing some cool AI stuff that all rhyme with having a lot of historical data and a known right answer. In fact, we would do things like based on your hand gesture, you could start the car or change the radio or make it colder in the room, like things like that. But they all model around the same idea of having a lot of historical data and known right answer. We would actually create a couple hundred photos of people doing this and actually rotating their hand a little bit. But we're telling the model, these are all variations of the same thing, right answer, right answer. And then it would find the patterns in the pictures to actually help and understand how those pieces fit together. Now, how did we actually measure whether or not this model was working well or not? I'm going to get into a little bit of math, but forgive me, it's not too much. But it's called a confusion matrix. And what a confusion matrix does is it compares, in this case, all of the rows being what we thought the guess was going to be, and all of columns are what the actual real data was. So in this made-up example, presuming you can see my mouse, if we predicted that we're going to see the word carry, and it actually was the word carry, we got that right 38 times. If we actually thought it was carry, but the answer was pickup, we actually got it wrong once. And so on and so forth, right? So everything along that diagonal here with the darker colors in it, that's where you expect the answers to be correct. We thought it was hold 43 times. Everything off that diagonal tells you where things are actually going wrong. So in this case with the heat map, you can kind of see some places where things were not very correct. We thought the answer was walk, but the answer was actually carry 27 times. Up here, we thought the answer was carry, and it was actually dig 15 times. This is where I can focus on in my data and collecting that historical data to get things right. So in the example of this car we were talking about, when we broke up the data by gender, by sex, by color, by types of things, we had noticed specifically that when blonde-haired, female-looking people sat in the car, the system didn't recognize things correctly. And so in what is one of the strangest job days I've ever had, I walked around the office and said, hi, this is weird, but you're female and blonde. Can we use you for training data in AI? Because we needed to get more examples of that scenario sitting in the car, making the correct gestures so we can actually create more historical data. There's an implication to that. And thank you very much to Gardner or McKinsey for letting me steal their slide here. The implication is AI is not a project that ends. AI should be considered a product that will always go on, always have to be retrained and improved over time. That's where this work comes from. But like I said, a lot of this stuff is really not figured out yet. AI, bleeding edge, right? It's called a frontier model from an LLM perspective because we're going too far down this road. Oh, wait, I was supposed to talk about ethics. To get to ethics, to get to bias, I need to go through a couple of steps and a couple definitions. So come along with me for this ride, but I promise we'll get there near the end. First, I want to talk about discrimination. As former Supreme Court Justice Potter from America said, discrimination, bias, I know these things when I see it. He was talking about something different. But nevertheless, the idea of knowing what we see is not good enough from a legal perspective to actually quantitatively judge these things. In Canadian law, we have something called protected classes. Protected classes are the various demographics upon which it is illegal to discriminate against. You can guess what a lot of these are, right? You can't discriminate based on someone's sex or indigenous background or their sexual orientation. There's a bunch of other factors as well. You can check them over on the CIHR website or talk to a lawyer. But fundamentally, every Canadian is not allowed by law to discriminate based on these factors. Two things that are interesting from this. Number one, you are not allowed to discriminate even indirectly. So if you have training data that has, I'm making this up, certain postal codes where postal codes are discriminating against protected class, that indirect discrimination is also not allowed. Secondly, and important for going global, protected classes are different among different jurisdictions. In the UK, socioeconomic status is a protected class. I cannot discriminate you. One cannot be discriminated against in the UK based on if they're rich or poor or come from a rich or poor family. We can do that here in Canada, legally. Now, there's a good discussion to be made as to whether or not we should. I'm not going to talk about that today. I'm just saying that it is legally allowed to do so here. Okay, so to understand ethics, we need to understand discrimination and protected classes. To understand ethics, we need to understand how to measure the quality of AI. Have you ever really thought about that? Like from a very high level perspective, to say that I have two AI models, whether it's Claude and ChatGPT or two little custom things about measuring pictures of people doing things in a car, what makes one better than the other? In the most statistics way possible, we look at the double negative. We measure quality of an AI by looking at the error, where error is just a very simple definition of not being right. So whether it's that confusion matrix we saw before about guessing the things correctly or not, or different ways, there's many, many different ways of measuring what error means. And that specificity really matters because it has longer term implications. If you've ever heard of terms like root mean squared error or MAE, there's a whole bunch of ways of measuring what error means, but your choice is important. So let's make up a very trivial example here. I want to build a model to predict the temperature outside today. I have a friend in Utah. It's snowing down there, by the way. I'm sitting here, it's beautiful and 25 degrees. Yes. Okay, so we're going to build a model to predict the temperature outside, and I'm going to define error as very simply the absolute difference between my guess and the actual answer. There's many different ways of building an AI model. Some are super complex, some are super simple. In this case, I have my actual data. Remember, lots of historical data and known right answers. And I'm just going to guess that the temperature outside is 4 degrees. Yeah, but Jim, people are outside in shorts. Don't care. It's 4 degrees. Yeah, to be clear, this is probably a very bad model, but it meets our definition of can I make a guess as to what I had based on historical data. So, because of my error is just subtracting the 2, it's pretty simple to say that 5 minus 4 is 1, 8 minus 5 is 4, and so on, so on, and so forth. I can sum up all of that error and say that over the course of my 5 examples, my error is 20. Now, I'm going to create a second model where instead of just guessing 4, I'm going to guess whatever the temperature was the day before. It's actually a pretty good model to say that whatever you're doing now, the guess is your next thing is whatever it was before. The stock market, probably generally what it was yesterday. I mean, that's not as true anymore, but it made sense like about a couple of weeks ago. If Jim takes 100 steps forward, what's his next step? Probably going to be a step forward again, right? Whatever we just did is a good guess. So in this second model, you'll see that I'm actually guessing whatever the temperature was the last day. Again, 5 minus 4 is 1, 8 minus 5 is 3, 12 minus 8 is 4. It does a better job of kind of tracking that pattern. So in my second model case, my error is 15. I could now quantitatively say, based on my assumptions and definitions, that that second AI model is better than the first. Now, how much better than the first? That's a great question. And we define that by something called forecast skill. Forecast skill comes from the meteorological days, the weather days of making good predictions outside. In fact, I remember a funny story from Toronto. The weather guy would actually get the fax machine. Here I'm dating myself. The fax machine with the forecast from Environment Canada. He would throw it out, look outside and say, hey, it looks partly cloudy. It's partly cloudy. Next day he would look outside after throwing it out and say, it looks like it might rain. Forecast, might rain. Now, it turns out he didn't do as good a job as predicting Environment Canada. I know, shocked emoji. But nevertheless, the idea of building that prediction can be different no matter what you want. In this case, the radio announcer, with his lots of historical data, was in his head and his gut, and he didn't improve and train it. So forecast skill is a method by which we use to determine how better a model is than another one. If you've ever done correlation stuff, this stuff rhymes a bunch with it, right? But what we're really looking for is that straight line again. So in this example of made up data that I have in front of me here, so the vertical axis is what we predicted, the horizontal axis is what actually happened. So we guessed it was 100, the actual guess was 6, that's pretty terrible. We guessed it was 19 and the actual data was like 39, right? Like these are really bad. This is not a good model for predicting the future. What we want is more of a straight line, right? We want a case whereby we suggest that it's, 15 and the answer is about 14. The second dot, looks like 79 and it looks like 79, right? That idea of having a straighter line means your guesses are more closely to what they're supposed to be. Okay, so let's define this now. Forecast skill is defined simply as 1 minus the error of the first model, the new model versus over the old model. So it's a fraction, right? That gives us 3 scenarios as to define the quality of one model compared to the one before it. If the error, remember the sum of the error, the 20 or the 15, if it's the same as the model we had before, well, a number divided by itself is 1. 1 minus 1 is 0. So that's this leftmost box here. The second model would be 0% better than the first. Makes sense, they're the same. If the new model had a really, really tiny error, well, think about it. A really small number divided by a very large number, basically 0. 1 minus 0 is 100%. So if a model gets itself perfect afterwards, it's 100% better than the one before. In our last example, if the new model you're bringing has error that's much, much bigger than the first one, well, think about it, right? A huge number divided by a tiny number is actually a huge number. It's like, well, it's infinite. In fact, the first time I did forecast skill for my very first job at Lixar, I had a skill of minus 2,000%. Like, you can do a terrible job compared to what was done before. But more importantly, for the purposes of today's presentation, we can compare 2 models and say which one is better than the other. So in our temperature made up example, to measure the skill, 1 minus new versus old, 15 minus 20, which is 75%. So 1 minus 0.75, 25%. That second model we built to predict the temperature is 25% better than the one previously at determining error. Okay, Jim, you're off topic again. Let's get back to ethics. To talk about ethics and bias, we needed to talk about discrimination. We needed to talk about protected classes. We needed to talk about quality and the ability to measure a model to understand how it's being impacted. Now, according to US Supreme Court statute, which does apply in the UK and Canada as well, bias in Griggs v. Duke Power is defined as the 80% rule. If a decision, in this case an AI model, impacts a protected class at worse than 80% than the normal, that is considered disparate impact. That is considered formal bias. I'll say it again separately, right? Griggs versus Duke Power defines something called disparate impact. Disparate impact means that your protected class is impacted at an 80% rate more than just other groups and demographics. So what does that mean? If you have your measure of quality, remember we're talking skill and quality and error, and in this case, you can see that the first 2 groups there, let's call those the protected classes, have a lot more error than the other ones. That is bias. That is discrimination formally and legally defined through precedent. Now, in fact, this morning, as I was doing some research, Trump's executive orders are talking about Griggs versus Duke Power. The whole idea of disparate impact is up for debate in executive orders right now. And so who knows? In 6 months, we might have a different definition and things might be differently. We're learning, we're flying this plane, we're building this plane as we fly it, and things are kind of changing quickly. But as of right now, disparate impact and a definition of bias happens at that 80% rule. This has a very significant and interesting implication that I found, it's funny, I actually didn't think about it at the time, but an AI model is not considered biased if it is terrible for everybody equally. Bad predicting doesn't mean discrimination. Bad predicting doesn't mean bias. It's just that if you can measure the quality across different protected classes, you can find and measure and implicate that bias. Because in the end, all of AI is just having lots of historical data and a known right answer, and from that building models to predict what you're going to see in the future. Thank you so much, everyone. I appreciate your time. Alex, I yield my time and give it back to you.
Thank you. We are completely unbiased against you for the time you've taken. In fact, we are very happy that you did.
I see what you did.
Thank you for such a thorough explanation of all of these kind of very abstract concepts, that it's a little tricky to kind of ground in a way that you can actually measure. I know when I took your course about this topic, I found this really interesting and a great way to kind of actually ground it in something real. Whereas you say being able to measure these things is much more powerful than just being able to know something when you see it, being able to explain it in a way that other people can also get behind. We have a couple of questions in the chat from Emily. We had one about Fair Squared. I think that's the name of the tool. I've been very interested in seeing the development of Fair Square by Frontiers. This is the dashboard which can help to write scientific articles based on data sets. This kind of tool continues to grow. How can we focus on creating sampling strategies specifically for ocean data that create unbiased data sets? Will there be new strategies implemented or changes to sampling protocols when we start to think about creating data sets for AI?
Emily doesn't hold her punches. I love it. What a tricky question, right? When you consider generally the four types of sampling available, random, stratified, et cetera, et cetera, et cetera, it makes understanding and data collection curation ridiculously difficult. And I fear, Emily, although I defer to Frank and Ann on this as well, I fear no good answer to your question. The reason why I think that is because to me, sampling bias and error bias is a function of what you're doing with the data rather than just having it clean. I don't think people can generally aspire to say this is a completely unbiased data set and there's no bias or discrimination within it because it depends on its purpose and function of what you're using it for. We can do our best to mitigate and minimize, or at least I would suggest, point out your assumptions and definitions so that people can use that and pass it through the workflow and lineage. But I'm open to being wrong here, guys. A strong belief loosely held, but you can't just say my data set is completely unbiased and never will be.
Thanks for answering that, Jim. I think she's also got
Wasn't
a
a great
follow-up
answer.
question
Sorry, Emily.
about what's that?
I said it wasn't a great answer though, Emily. Sorry about that.
I think she also had another follow-up question about the relationship of U.S. Supreme Court to practice in Canada and the UK. In the side chat that maybe you can address there. We can also maybe take some of those questions later in the full panel discussion. Oh, here's one from Hassan as well. Any idea how to deal with generated AI data? How to integrate it with other observing data?
This question mean like taking a Anthropic or an open API and using that as part of our created data set? At least I'll interpret it that way.
I'm assuming kind of like using interpolated data.
Yeah, that's where my mind goes too, right? The idea of actually creating simulated data and using that to train models has some fascinating research out there. And so if you're going to Google stuff like data simulation or simulation training. I'm familiar and actually good friends with Dr. Lisa De Bruyne out in Scotland, who's working on the faux data set, like an entire R library that creates fake data for you. I would suggest the biggest thing from a hot take perspective you want to care about is making sure that the aggregate parameters of the data are the same. I've added a bunch more, but the mean, the distribution are the same. The variance, the standard deviation are is what it was before, because you don't want to fake that data. There's nothing better than ground truth. There's nothing better than real, actual stuff you have. But whether in image training data, where you kind of jiggle stuff around to create lots of different variations or flip the images around, there's the same equivalent across ocean data, water data, text, and numerical data as well. If you can't stick with ground truth, if you're going to make simulated data to train models, be really, really careful about what you're doing, because you can start just creating garbage if you're not intricately aware of what's going on.
As they say, garbage in, garbage out. Thank you, Jim. That was very interesting. Appreciate you sharing your expertise. Let's head on to our next presentation and move things right along. Next up, we have Dr. Frank Rudziks from Dalhousie University. Frank is an associate prof at Dal, faculty member at the Vector Institute for Artificial Intelligence and the Canada CIFAR Chair in AI. His work is in machine learning in healthcare, especially in natural language processing, speech recognition, and safe AI. His research has appeared in popular media such as Scientific American, Wired, CBC, and the New York Times, and scientific press such as ACL, NeurIPS, JAMA, and Nature. Without further ado, Frank, please take it away.
Great. Can you hear me and see my slides?
Yes, we can.
Awesome. I think I'll be pretty brief, and then we can have that 5-minute break that we were promised an hour ago or so. I'm going to go through my conflicts of interest quickly, because some of these are, so Winterlight Labs is a company that I started with my students that uses machine learning to identify signs of neurodegeneration from speech. That company was purchased by Cambridge Cognition, in which I have shares now. Autumn is another company started by some of my students, essentially the same kind of technology, but focusing on mood disorders. That company was also acquired. Surgical Safety Technologies, I didn't start, but I joined them as a director of AI for a number of years. And they're going to come up in my presentation. We used, speech, video, a variety of data sources in the operating room to improve surgical safety and efficiency. But I left that company, but I worked there nonetheless. And then finally, Mutual Health Solutions is a company still other students and I started that uses speech recognition and large language models for scribing kind of conversations between primary care doctors and their patients to improve efficiencies in primary care. And that company was also acquired not long ago, and I have shares in HealWell. So the first thing I'll do is just touch on a couple of topics that I think are important for us to remember when we talk about AI generally. I like to say that I've been doing AI since before it was cool, and I've seen the pendulum of hype versus fear shift back and forth a lot during my time from a student until now. It's a little bit frustrating because I think, despite all the conversation about all the risks of AI, safety risks, risks to our jobs, and so on, there's equally unfounded claims about uh, how perfectly it works and how it can code any challenge and how it's better than doctors and lawyers at various tasks and or the overhype. The thing we have to remember is that the reality of AI is somewhere between the hype and the fear end of the spectrum, and we have to continuously just check our biases to make sure we haven't been radicalized one way or the other. Generative AI is amazing. It's not exactly a new technology. I mean, a lot of the fundamental building blocks of what we now call generative AI are, maybe 5 or 10 years old. But generative AI itself, the predicting of words or tokens from previous data trained into a model goes back to as early as 1948 when Claude Shannon proposed it. So when we think of AI and we think of the recency of AI, we have to remember that there's a very long history of it, which was touched on very well in the first presentation. Also, AI isn't just ChatGPT, and it isn't just large language models either. Again, I work mostly in AI and health, and sometimes someone comes to you and says, we've decided to use ChatGPT to identify falls based on like wearables or something like that. And I find that to be a bit ridiculous. Like you don't need a model that can literally tell jokes and write poetry to just tell whether or not the accelerometer indicates a fall. That's some technology you could run on a wristwatch. So, again, AI isn't just one thing. There's a wide variety of solutions. And finally, like LinkedIn has lots of benefits and, as a social media site to keep up to date with news. But, it's not a scientific journal. There's a lot to the topics we're hearing about today that aren't normally part of the kind of discourse you see on social media like LinkedIn and TikTok. And if you want to understand why AI is neither at the hype end of the spectrum or the fear end of the spectrum, it helps to dig a bit deeper than LinkedIn. Very quickly, there's various ways of taxonomizing what responsible AI actually is. I'll get to a few of those later on, but I'm just going to quickly touch on 4 kind of key, more or less distinct pillars of what can constitute responsible AI. The first is the idea of transparency, and this also is a big umbrella term. Transparency often is associated with what we call explainable AI or interpretable AI. So what that means is explainable AI usually refers to, can we understand what the model has learned, like what the model has learned internally? Interpretable AI means an AI has made, I'll use the term, a decision, and we want to know why this patient was diagnosed with cancer or why this customer was denied insurance. So for specific data points, why decisions were made is the purview of interpretable AI, which is still under the umbrella of transparency. For those of you kind of working on deploying AI, it can be very important to be able to either explain models or interpret decisions, because they're going to come to you with these questions and you're going to have to be able to answer them. Fairness is a very massive umbrella term, which I'll get to a bit later. And we heard this a bit in the previous talks, especially like just now we heard about kind of the different ways that fairness can be quantified. And this is also a big challenge. So various kinds of biases can creep into the data, like you just heard, in ways that don't reflect all customers fairly. And if you're building a model in one scenario or site and you want to deploy it somewhere else, you have to make sure that it'll work effectively there. So if I'm building an AI model in Copenhagen using Danish data, and I want to deploy it in Nigeria, for example, with non-Danish data, you better make sure that your computer vision technology can detect variations in skin color, like we just heard about before. Again, from the point of view of businesses, it isn't, I mean, fundamentally, it should be just about the fact that we want to do the right thing, and we want to make sure that there's no group that is biased against. From the cynical point of view of companies, it's a good idea to make sure that your models are not, overly biased to one group or another. Accountability, again, from the point of view of a company deploying AI, at some point, mistakes will be made, and it's possible that an organization might open itself up to risks of like legal consequences. It's still an open question about who is responsible for decisions made by AIs, but it's very important that we have processes in organizations that can help to kind of track the development of a model from the acquisition of data to its pre-processing through imputation techniques, to training, retraining, validation, deployment, monitoring, and so on. Who is responsible? Where did the data come from? All of those steps these days can be very easily kind of documented using tools like MLflow and others, or processes that touch on, say, SOC 2 and that sort of thing. So accountability is something that usually is an umbrella on top of AI, but it's still very important when we're talking about deployment and responsible deployment. And finally, privacy. I'll talk a little bit about this again also. It's not just the data that we need to respect and protect. It's the information contained in those data that seep into the models we train and then deploy or potentially share. So there's lots of frameworks by which we only collect the data we absolutely need, which can make discovery-based research like AI tends to be difficult sometimes. But those frameworks exist nonetheless. There are various privacy tools that can be used to anonymize data, and we'll talk about differential privacy in a bit. We want to make sure the models are private. Models are, in some sense, a lossy compression of the data. So if information existed in the training data you use to make those models, now there's a strong potential that they now exist in the models. As you have to be sure that, before you share those models, you make them as private as possible. And just on one hand, there's legal obligations to protecting the personal health information or personal information of your customers. But again, this is also just a cynical business interest. Patients are going to want to know that you're not taking advantage of them through their provision of data for you. So having strong privacy pipelines in your organization is likewise very important. So it's very easy to talk about the risks of AI in what we would often consider the wrong hands. So whenever there's an election and we think of this country or that country interfering in our elections, we often subsequently think of them using AI to flood social media, like LinkedIn and others, with posts that are in the favor of their preferred candidate. And then now, I mean, I've been saying this for a couple of years now, as thousands of others have, but there's a risk that the power of AI being increasingly consolidated within a handful of 3 or maybe 5 companies might not be globally optimal. So there's lots of things we could discuss about the risks of AI being used by countries that might not have Canada's best interests in heart, or private organizations that also don't have the public interest at heart. But another issue that I think is potentially just as dangerous is AI in the right hands. So your hands, my hands, the people developing AI, whereby we're trying to do the right thing. We're trying to develop like an open source model that can be used to detect disease early so that it can be treated early. It seems to be a noble goal, and it can be done in full, respect of these key principles of responsible AI. There are various problems. So some of these problems include including goals that are too abstract. So merely trying to be as accurate as possible or trying to minimize error to the maximum extent possible can result in various kinds of challenges, like essentially tricks or the clever hands effect, whereby the model will latch on to elements of the data that maximize its score on training data, but ends up finding some shortcut to making its decisions that are not what we'd intend. You might have heard of a computer vision model that looked at skin lesions on the skin, and it was meant to look at those lesions and detect which skin lesions are malignant and which ones are benign. And it turned out that in the situations when the lesion was malignant, like it could have been cancer, there tended to be rulers in the image because the doctors who collected this data were very careful to measure the growth of these images because it was dangerous and they knew it. So the model sort of latched on to the idea that, well, if there's a ruler in the image, it must be malignant, right? Which is not the behavior we want. And unless we catch that, shortcut, then when we deploy a model, it's not going to behave the way we want, which is very risky. I'll talk about three biases very quickly. The first challenge is bias. This is a paper from some colleagues of mine at the Vector Institute. What they did was they had a chest X-ray data set called CheckSpurt, and they basically wanted to identify whether or not there was a disease present. So wanted to diagnose the disease. This paper is a little bit, can be confusing because they considered false positives and no findings to be synonymous. Normally, when we consider a false negative to be when something actually exists, the disease is actually there, but the model thinks it does not exist. That's a false negative. That's an example of underdiagnosis. The person comes in, gets an X-ray, they have the disease, the model thinks they don't, they're sent home. The cancer grows, and then they have to come back, weeks or months later. It's worse for the system, again, cynically, because it costs a lot more to treat them, but it's also, more importantly, much more dangerous for them. So we want to avoid this. And this paper basically studied any variation in sex or race and a few other factors on underdiagnosis in this particular model trained on this data set. I'll just fast forward a little bit. The results are not surprising. So women had statistically significantly higher rates of underdiagnosis. Young people, ages 0 and 20, had significantly higher rates of underdiagnosis. People of color, again, significantly higher rates of underdiagnosis. This is an American data set, so they have like this difference in how people access healthcare down there. But people on Medicaid, so lower socioeconomic status, also had significantly higher rates of underdiagnosis. So a model trained on the data ended up being sexist, ageist, racist, and so on. Now, the thing that we have to remember is that it's not like AI itself is introducing the bias into healthcare or these model. These biases are already there. Okay, so healthcare is already biased against women, against people of color, and so on. The model, like I mentioned a moment ago, finds shortcuts to be as accurate as possible, and then it sort of inherits these biases. So on one hand, it's not AI's fault, but on the other hand, because of these shortcuts, AI can, in some sense, exacerbate or accelerate these biases. So it's still a big problem we have to deal with. One concern I sometimes have when we're having these conversations is that we don't sufficiently respect the idea that there's many kinds of bias. We talk about bias being bad, but at some point we need to systematically model and filter out those biases. We need a mathematical way of identifying bias in the first case, and then possibly, filtering it out afterwards. There's not too much math in this talk. This is, I think, one of only two equations. Equalized odds is one of dozens of mathematical formulation of fairness in which we look at fairness at the group level, and we say the probability of you being diagnosed with the disease depends, on you actually having the disease, which is Y, the ground truth, and whether you belong to group A, white people, or group A prime, people of color. That should have no effect on the probability of you having a positive diagnosis. Right? So the probability of a positive diagnosis only depends on the ground truth, not on the, in this case, racial group you happen to belong to. So equalized odds is a formulation that we can apply to models in order to equalize out the odds of a white person, a person of color getting diagnosed appropriately. It's not a silver bullet. It doesn't work perfectly, but it's one of, again, dozens of formulations that we can use. Second of three, privacy. So I mentioned a moment ago, AI is often referred to as a discovery-based science. It's hard to say we need exactly these pieces of data. Rather, people who work on it normally say, give us all the data you have, and we'll search until we find something that is helpful. Obviously, this is a problem with regards to privacy, right? Because especially in healthcare, normally we don't have access to a lot of personal information that could potentially be useful. So here's an example of what we did in the surgical safety technologies company. This is all public. We had cameras in the operating room looking at the surgical team. The surgical team did not want to open themselves up to litigation, so we had to use an AI to identify bodies, and then blur it out with some simple, graphics code. So this is the result of it. So you can kind of see the model has figured out the contour around this person. We've blurred them out, and we've especially blurred out the face. Like it's pretty easy to determine where the head is. So here's the problem, right? A surgery can go on for 2 hours. We were recording video at the rate of about 60 frames per second. So 60 frames per second, 60 seconds per minute, and so on. You have a lot of frames, which we have to de-identify in this way. And hypothetically, let's say, there can be a situation when this person is walking across the room. AI can kind of struggle to keep up when there's a lot of movement sometimes. So there could be a case, again, hypothetically, where a small fragment of the sneaker is visible. Suddenly you see that the sneaker is red. You see that this person is spending all their time by the anesthetist station. Maybe there's a clock on the wall so you can see what time it is. Now you have the breadcrumbs. There's an anesthetist who wears red shoes who was in this operating room at this time. Now you've re-identified this person given only one frame of this 2 hours of video. Similarly, privacy-preserving techniques are often the standard of care or the standard to take clinical notes like text, find out where the names are, and then blur them out in some way, replace Arnold with name, Smith with name, and so on. Some of these technologies are like 99.9% accurate, which sounds great, but if you have a population of 40 million Canadians, that 0.1% can result in thousands or tens of thousands of people, or certainly data points, which have not been obfuscated. Someone has an atypical name, the model doesn't pick it up. Suddenly that person's name is no longer de-identified. The solution to this, amongst many, is something called differential privacy. I'm not going to go into this just for the interest of time. Differential privacy basically involves taking the confusion matrix, which we saw a few moments ago, adding a good degree of noise to it so that you no longer can really tell to which group a person belongs to. So after this noise is added, you have a data point. Is this data point a man, a woman, white person, person of color? Now, within statistical bounds, you don't have a high degree of confidence on any of those things. So a white person looks like a person of color after you've applied differential privacy. Here's another challenge. Privacy and bias work at odds at each other. So this graph here shows the influence that patients have from a training set on a model, right? So a particular person's data point can have a lot of helpful influence on the decision-making of a trained model on a validation set, or it can occasionally be harmful also. So you see all these patients lined up along the x-axis, and the y-axis indicates the degree of helpfulness or harmfulness. When you apply differential privacy, again, you remove information about these patients, so they all kind of look the same, speaking loosely. That's this red bar over here. So now every patient has the same amount of influence on decisions made by the model. The problem now is that it was actually helpful when you're making decisions for, say, Black people, to know about the kinds of diseases that Black people might be more prone to. And now if your model has just a bunch of people who all appear the same, where race has sort of been removed from the model through differential privacy, now the majority of people in that data set, i.e. white people, now have an inordinate amount of influence on the decision for this Black person, and the performance the success rate for these Black individuals in the validation set is going to go down. Things were bad before for these various groups, like we saw a moment ago, and they can get even worse if you've applied privacy techniques. There are solutions to that also, which I don't have time to get into. I'll wrap it up very quickly. There are many frameworks for ethical AI. One of the first ones we tend to see is prima facie duty. This comes to us from biomedical ethics. Prima facie duty theory is sort of the framework that a lot of research ethics boards use when evaluating projects. There are more or less four principles to them. There's respect for patient autonomy. This generalizes to user autonomy generally. And we see this through informed consent processes. Non-malfeasance. So, this is often juxtaposed with the idea of doing no harm. Sometimes you have to do a little bit of harm, especially in surgery. You have to cut the patient, but it's always in the benefit of, or the pursuit of the third pillar, which is beneficence. So you're doing this for some benefit. And then finally, justice. Again, this is a top-down term. So the idea of fairness is kind of poorly defined. But if we have our dozens of mathematical formulations for what fairness actually is, we can actually implement some of this. There are many frameworks that exist now specific to AI. The Asilomar principles are guidelines, again, kind of top-down, that describe the ethical development of AI. The European Commission has ethics guidelines for trustworthy AI that you need to know about if you want to deploy in Europe. Then there's more bottom-up tools or tools that you can use kind of in more practical applications. Microsoft Responsible AI resources are among them. I'll share these slides, I think, at some point, so you can just scan these QR codes, and Datasheets is a really great framework to actually code up these things. And again, just in the interest of Canada, Montreal Declaration of Responsible AI is a made in Canada approach to ethical AI development that focuses mostly on sociological principles like well-being and democracy, traditional Western values. Lastly, I'm going to make a plug about, just speaking of like Canadian AI ecosystems. It's very important that we, as mentioned before, that Canada is like fifth on this list of countries in terms of our AI output. It's important to maintain that privileged position or even augment it. We need world-class talent to be here, and we need to keep it here. We'll need to make sure that when we're collaborating between hospitals and companies and universities around responsible AI, we can do so in Canada without having to look elsewhere. To some extent, this includes funding opportunities. There's tons of, I'm a professor, so I like looking for funding opportunities. It's often really helpful to do that if you have pan-Canadian representation. Yeah, basically, like I mentioned earlier, it's helpful if we can build the capacity in Canada, the infrastructure in Canada, so that we're ensuring that when we're developing these very important and consequential tools, they align with the public interest. And finally, at Dalhousie, I'm the director of this new AI Institute we're putting together, which one of the core pillars of the Institute is responsible AI. Part of this involves education on what responsible AI actually is. Part of it involves connecting researchers, professors, students, companies to solve real world problems. And then tons of other things. We're still in the kind of the beginning phases of this institute. So like our governance documents are still coming together. So now's a really good time if you're interested to be in touch to see if we can work together and formulate something that works for everyone. Here's a quote I like: "First we shape our tools and thereafter our tools shape us." This is Marshall McLuhan, and we're clearly in this second phase now where AI is having a massive effect on humanity. Thank you so much.
Craig, that was awesome. I think that presentation and the last two as well do a really great job of highlighting the need to maintain the human agency in the relationship with AI. And the importance of thinking critically about how we translate between how we think and how machines think and what the outputs of that are. We're a little bit over time. We promised a break. I know, Anne, you have some time constraints as well. You've been hard at work answering some questions before that. Panelists, would you like to keep to the break, or would you like to jump right into questions in the interest of time, just to maximize the opportunity of having you here? What do you think?
If Anne has time constraints, we should probably jump right into it.
Agreed.
I can stretch locally.
Anne, does that work for you? You want to make sure that you have a good buffer
Yes, thank you. I can stay for a few minutes, no problem. Thank you.
Sure. All right. Well, folks, we're gonna go right into our question period then. So feel free to submit questions ideally in the Q&A for any or all of our panelists. We probably won't have time to get to everything. If you have anything specifically for Anne to catch her before she goes, maybe we can get those in as well. But we'll start off with a couple of questions from our partner organizations just to kick things off and give people a little bit of time to formulate their own questions. And we'll ideally be able to field any that go unanswered to our panelists and get those to you at a later time. But thank you everyone for your presentations. Those were all really, really interesting. Really appreciate sharing your insights and taking us through the full range of the hype and fear pendulum that I know we're all oscillating on. Let's start off. For our first question, reports estimate that by about 2027, AI will use more energy than a small country, which presents a staggering environmental cost. Given this, when is the juice worth the squeeze? How do we balance the benefits of AI with the environmental cost of its development and its use?
Maybe I can start. I always say that responsible AI is about choosing proportionally for the usage that you need to do. For example, now people are tending to say, I don't want to go on Google. I want to make a lasagna. I'm going to open ChatGPT instead. But that costs a lot. And it's not proportional of what you want to accomplish. So I think being mindful of what the tasks need to do and the value that you want to bring is really important. And the other example is, for example, if I have only one task in the morning is to bring my kid to kindergarten and the speed limit is 30 kilometer per hour and I decide to buy myself a Ferrari, well, that's an overkill. That's really disproportional for the task I need to do, and I creating more risk on the environment. I creating more risk because the car will go faster than I would like it to be. So choose wisely and for the task that you need to do. So think proportionally. So that's the first step, I think. It's a small step, but it's changed a lot of things.
Thank you, Anne. Would either of the other panelists like to comment on that either?
I mean, we could wax poetic about externalities till the cows come home, but that's probably more than a 20-minute conversation. That we're not measuring and accounting for economic externalities correctly makes it difficult to do a proper cost benefit in people's minds.
All right. Let's go on to the next question. This is from our partners at SLGO, St. Lawrence Global Observatory. AI is a rapidly evolving field. How do you keep control over data management and integrate ethical practices that can take time to put in place?
Can you repeat the question? I'm trying to answer the text ones right now.
Sure. How do you keep control over data management and integrate ethical practices that can take time to put in place?
Sometimes you get that for free if you're a company, like I mentioned SOC 2, for example, like often, or depending on the discipline or the area in which you're working, or the segment in which you're working, sometimes you have to follow some principles um, by choice. You have to do it. I think the main challenge sometimes can be when you have a team that's charged with actually implementing some of these techniques and they don't know the full variety of techniques that are out there, or they don't know the ways in which they might kind of interact with each other in unforeseen ways. It's not so much the implementation of the principles or the identification of the principles, it's that the people on the ground don't know how to implement it or how to monitor it or what questions to ask. So I think like part of it is to get educated as soon as possible and making sure there's a team that kind of keeps up to date with some of the changes in the technology, right? So like you could have something that you could have a principle saying you need to make sure that personal health information or personal information is removed, but what does that actually mean? What varieties exist to differential privacy? Your team has to know what they're doing.
Awesome. Thanks, Frank. Any follow-up from Jim? Oh, sorry. I just wanted to acknowledge that Anne has gone to her next engagement. So thank you, Anne. No, you can't hear us for joining us. Jim, would you like to follow up on that question or Frank's response?
Nope, what he said. Dr. Woods is bang on that one.
Easy enough. Next question is from ONC, Ocean Networks Canada. When training AI models on non-public data, such as Indigenous community hydrophone data, what ethical considerations must be taken in broadly sharing such models?
I am currently working with the Canada School of Public Service, although I'm not here representing them, and I'm in no way advocating and saying this is a claim from them, but I do know that there's a lot of work going on and training around Indigenous data and how to handle it. I'm not in any way comfortable answering that question from a factual perspective and would suggest to reach out to people who are far more knowledgeable from a legal and or cultural standpoint to know how to best answer that question.
What he said.
Sounds good. Thanks, guys. Any questions coming in from the chat or the Q&A box, or any that we haven't gotten to from earlier in the workshop? I'm just taking a look at the tally for answered. Don't see any more. If we've missed your question, can submit it back into the question and answer box. We've still got about 10-15 minutes with company of both Jim and Frank to answer your questions. So feel free to take advantage of that. While we're waiting to see if we get some more questions from the audience, we'll go back to, oh, hey, Seus, what's up? Was that an accident?
Yep.
All right. All right, let's go on to another question then. Large language models like ChatGPT are often being used to outsource cognitive tasks such as writing, but writing is a skill that has to be practiced and trained. And by relying on these tools, it can be that we're degrading our own abilities. How can AI be used effectively while still preserving the human skill? Where is the balance?
This is a big important question that I also think I defer to someone else. There's again, being at Dalhousie, we have one of the members of our faculty, Dr. Christian Bloin, is in charge of sort of the university's response to AI use in class. And there was an article that I'm sure Jim will correct me if it's at the New York Times or the New Yorker about AI being used in education.
New Yorker.
New Yorker, yeah, thanks. And like, there's not really an easy solution to it. There's tons of problems, right, that people have identified so far. And it's not really clear how we can, like how a teacher, like at an elementary level or even at the university level can get around the problems that we're seeing, other than things like making sure that assessments are done like in person with a paper and a pencil, and so that ChatGPT can't be used in the first case. I also like will have to defer a lot to people who are working more actively in this area, but from a personal point of view, you know, like I have ChatGPT available to me, and occasionally there's times where it's like late at night and I'm like, I need to do something like highly administrative and not doesn't require too much cognitive ability, and I need to just hash out an email or something, and it's very easy to go to ChatGPT to do it for you. But even if it can do a really good job, sometimes it's important to catch yourself and to like try to build your mental muscle a little bit, because and just do it yourself, right? Even if it's annoying, or especially if it's annoying, try to do it yourself. There's not too much that like you have to learn with regards to having to write an email yourself. Like it's just writing an email, but that's one of many parts of human skill. that we risk losing, just communicating with each other. I don't want to be 5 years from now and I forget how to write an effective email because I get ChatGPT to do it all the time. So it's good to, just like with the exercise you do, if you do exercise, to keep it up and you're keep on exercising your mental muscle.
Joke's on you, Frank. I never wrote good emails in the first place. Yeah. Point, we're going to lose how to think. Counterpoint, I use a calculator. The answer is somewhere in between. I'll respond with an analogy that I think works really well. I use ChatGPT or equivalents to do software coding. And I've literally taken 3 months of work and done it in 2 weeks, right? It's incredible. What it doesn't do is make a junior person, or like my mom. Hi, mom. I love her to death, but she'll never code well and she'll never vibe code with an AI system, right? There's a comprehension that needs to occur such that I can look at the results and be like, nope, that's not right. Fix that bit. And the big gap in software development is how do you make juniors into seniors when they're not doing the work anymore? And I don't have a good answer to that yet. Now replace software with emails and you have the same thing that Dr. Rudis was talking about as well. And I don't have a good answer to it.
Yeah, it's a general trade-off with kind of just technological advancement. What are the trade-offs of taking this shortcut, and what do you not gain from the experience or from opting for that choice to address something instead of doing it all manually? Because you can do it, you can do something much more slowly and think a lot more slowly, but that takes time, and time is a valuable resource to a lot of us. Here's another one from SLGO. How can we ethically document the methodological choices made at a given time, presumably in the development of AI tools?
Much of this counts as ethically, but if you're documenting the choice of a particular model versus another model, uh, often you do some A/B testing or some other kinds of validation locally first before you choose to deploy a model. This is still kind of the case, right? So it's very common in academics where you're like, here's a baseline or a set of baselines, and here's our model, and here's how it's different and everything. This is what companies have to do also when they're thinking of deploying like one kind of model versus another, or they're doing an ablation over like the complexity, like the size of the model. They're going to do lots of experiments, and again, if you're using a tool like MLflow or weights and biases or one of these other tools that can like monitor and store previous runs or previous results, then that'll be part of your record. Like when I worked at some of these companies, that was part of our SOC 2 compliance thing, yeah, and then that tends to make it a lot easier. You can say, well, we chose this model because on this data set, it had the best metric, and the metric, I mean, often you end up running into the problem of making the metric just accuracy. And as I think several of us talked about, like, you have to also account for other kinds of fairness related metrics. And if you have all those pieces together, that's sort of part of it.
Yeah, plus one, what Frank's saying, right? The ML flow and what the Databricks people did in release is really great. There's a world where whatever C27's next feature is, where if you're using an AI model, you need to provably show and auditably show this person had this decision because of this model that was trained on this date by this data that had this metric. So that traceability is coming regardless of how you're going through. My response to that question comes from a private sector world. Like if you're doing software development and design properly, like your ability to make work and make outcomes necessarily shows how the decisions come in as well. And AI should be no different.
Yeah, some of these
Said otherwise, if you're not doing design, like, come on, go to design. Do it properly.
Not everyone's necessarily interested in proper design. Sometimes it's just the outputs.
Sure, but then you can't come to me and complain about not knowing if you have a strong ethical choice or not.
We have a question from the audience. Many AI systems function as black boxes. What can be done to improve transparency and explainability?
Ugh, I mean, sorry, Frank, you can probably go ahead first because you actually talked about it with your example, right? One of my presentations shows it was a dog versus wolf, same thing as Dr. R did, but she showed that snow in the background always made a box, right? So whether it's a system called SHEP, whether it's a system called feature compliance, whether it's called LIME, there's different ways of actually looking at the explainability of black box models by seeing what goes in and what pops out.
Yeah. All right, go ahead.
I was going to say, I realized I said I should stop talking and let you talk, and then I just kept on talking. So I apologize about that.
No, it's perfect. You mentioned like Shop and Lime. I was like I'm responding to this question right now also. So I'll just send this out, but basically the same thing. I think the only two things to add is that like sometimes these methods don't work perfectly either. Sometimes people think if we use explainable AI, it'll give us a real explanation of the model, but like the explainable AI techniques can also be errorful in some ways. And you know, like so there's when using these massive models, sometimes people there's a paper called Attention is Explanation, and there's another paper called Attention is Not Explanation.
Yeah.
And so like you know like GPT and these other transformer models use like attention within itself to say, well, I made this decision because of these elements and the input, but like they don't always work so well. So you have to be careful. Like explainability is not a silver bullet either.
Jim, I noticed that you'd started tackling this one in text. How do we define responsible AI, and who gets to define it? Who makes that decision?
That's a political and governance question, right? I would argue, because I'm big on democracy and freedom, that should be the role of government and elected officials in sovereign states. Because like anything else, this is policy as to what we define as a people to be the word responsible and the word AI.
So this doesn't necessarily get decided in a paper.
So with the full disclosure that I'm a volunteer with a charity called For Humanity, who's building audit criteria on ethical AI, our way of thinking about it is that we want to develop the engines and protocols and frameworks on how this works, right? Strong ethical AI means as an organization, however you define organization, this is what we believe and this is what's important to us, right? And so whether that's a government enacting laws or Dalhousie University making its own policies, like this is what we agree and this is important, this is what drives us in terms of our vision and policies and regulations. That just becomes from elected representative and agency of the people.
Frank, any input on that one? That was the who gets to define what responsible AI is?
Yeah, I also like would defer to Jim. So like there are like experts who study this, who get together either in like standards committees or government-led committees. Like I mentioned a few of them, like the European Union is kind of taking off ahead of us in terms of their definitions of some of these things. But it's one of these problems where it's I think there's always going to be some disagreement about certain kinds of aspects. Um, like um, like is utility important? So like if a person if a system is biased, like imagine you have an AI system that is used to help hire people for a job, and we know those to be biased in various ways, but maybe they're biased against children or something like that. Maybe that's a bias that we can accept as acceptable, um, and others might not.
Yeah, people are kind of inherently biased, but it's what you do to minimize as much of it as possible. So
And to throw a big fat wrench into that, like industries like insurance are by definition discriminating people, right? Based on your risk profile, we charge you more, and that's by design.
This one's maybe more geared or Jim, this might pertain to you as well, but maybe more directly to Frank. How does academia deal with the fast changes and developments in AI landscape happening in industry?
Coming up on 2 decades since my master's, so I'm going to certainly defer to the active professor on that question.
It's getting a lot more difficult, to be honest. Like there's the name of the game now is just scale, and a lot of like universities just don't have the same capacity as massive companies do. You might remember that a few months ago, the Canadian government announced like this massive new pan-Canadian AI like reinfusion of funds, like in the order of about $2.5 billion or so, which is a big deal in terms of national governments. I think Meta, the cost of training their Llama large language model was something like $20 billion. Maybe it was more than that. So the entire Canadian government is like, an order of magnitude less effective in funding AI than one Californian company. So yeah, it can be a bit of a problem. So a lot of academia is shifting to more detailed or nuanced level challenges. And we're not doing a lot of the complete training and fine tuning that we were doing 5 or 6 years ago. Instead, a lot of our research is at the level of like either explainability techniques or, I hate to say it, but kind of prompt-based techniques. And that kind of thing, or elements of deployment. So if you're working on AI, especially in oceans, you don't need a large language model to do this work. You can still get by with a strong, multi-million parameter model that can run on a GPU under your desk. So we're still doing a lot of that kind of work. That work tends to be more applied AI and not fundamental AI, but it's still super important. And so, like, if you're trying to deploy something to run in any scenario, all the questions of distribution shift and like other aspects of deployability just still come up. So I think academia is shifting more kind of in that sort of direction. We're becoming more of the validators of technology as opposed to and we're ideating a lot of stuff too, but like being able to train it now is getting more challenging because of funds.
So there's a fire hose of all of this information coming out every day. You two obviously have your finger on the pulse probably more than the average person. How do you keep up with all of the changes, all of the new things happening? Or how do you best manage that?
Usually my students come into my office and tell me about a paper that they expect that I read, and then I act confused for a little while, and then they go away and I read the paper that they were talking to me about.
In a very similar way, I'll be on Blue Sky and see a joke by an AI person that I don't get, and I'm like, oh, I'm behind, and I need to go figure out what the joke is in the context to see the bigger picture.
Yeah, I need to go learn so I can laugh at this.
Yeah. We fake it till we make it. Hi everyone. That's your dirty little secret.
You fake it until you become it.
No, it never goes away.
I don't think we have any more questions coming from webinar, but feel free to keep submitting some, and we'll make sure that it gets answered at some point, maybe not in the next couple of minutes. But here's our last one from our partner organizations. What are your biggest hopes with respect to AI? There's a lot that's kind of concerning, but what keeps you kind of so passionate about this stuff and spending so much of your time working on it?
I can go first. So I think the reason I got into AI initially, AI in healthcare anyway, and again, I hope this generalizes to the fields that others are working on here, was sort of like the balance between the fundamental theoretical aspects of AI and then the applied aspect of it. So there's an awful lot of good we can do in the world using AI, right? So we can, for example, like detect cancers months earlier than we've been able to do it currently, right? And there's very little risk often or extra cost to do that. So we have a lot of potential solutions out there that would just make society massively better, and they wouldn't have a lot of these negative consequences of losing your skills or replacing workers. You'd augment workers, and then those workers could also develop other skills that they wanted to use in the first place. So I think the kind of the low risk, high reward implementations are still like they haven't been implemented yet, but they're right there. So that's kind of the main motivation.
Awesome. Thanks, Frank. Jim, how about you?
I'm a nerd and computers are cool.
That'll do it.
It's a very sincere and vulnerable answer more than anything else, right? Like if I'm 6 years old and playing on my Commodore 64, this is just the next continuation of things that I find interesting to do.
Yeah, curiosity is the key. Even if there's anxiety. Thanks, Frank. Thanks, Jim. Thank you, Anne, wherever you are. We got a couple minutes left. I'm gonna get Spencer to come up on stage here to plug an event that's happening right after this. Spencer Bialik is with ONC out west in Victoria. Spencer, you can tell us a little bit more about what's going on.
Hey everyone. Yeah, I have a talk in about 15 minutes. And you can come join it if you want to hear about how I'm using machine learning to modernize the infrastructure that Ocean Networks Canada has for monitoring underwater sounds and finding some anomalies, some anomalous data in this underwater acoustic data. Thank you.
Awesome, not to be missed. Excited for it. Thanks, Spencer. We'll see you soon. Thank you, everyone, for being here today. If you're interested in continuing your AI learning journey, Building Bridges has more upcoming workshops that will feature more hands-on learning. We have Spencer coming up right after this. Feel free to reach out to us or our panelists if you want to learn some more. If you're in Halifax, CUS Atlantic is hosting an in-person workshop. Details are in the chat. St. Lawrence Global Observatory is hosting a workshop later in the month on open licensing for science research in collaboration with Creative Commons. So we hope to see you at as many of those as you can make. We really appreciate you being here today with us. Lastly, if you would like to stay connected with us, you can find us at cusatlantic.ca /building bridges dive into that's in the chat. You can follow that more effectively. And on social media as well, or you can email us at info@cusatlantic.ca. Big thank you to our panelists for joining us and sharing their experience and expertise. And thank you for all of you for sharing your time with us to learn something new. And finally, we'd also like to thank our partners and our funders, OSC, DFO, and MeoPar for making this possible. This has been fun. Thank you for sharing your time with us. Hope that this has been helpful to all of you in the audience who are still with us. Hope this is just a stepping stone and that you keep curious about what is happening in AI and what its potential is and what our relationships look like with it. Because this is changing every day. It's exciting, it's scary, but it's exciting. All right. Thank you, everyone.